Hello. Good morning or good evening. Anna, can you hear me okay?
I can hear you good.
Yes, and good
Hi,
morning
everyone.
to yeah, hello everyone. I think we have folks everywhere today. I'm looking at the chat now. I'm almost jumping straight to that. Yeah, welcome to everyone and good morning from Chicago. This is exciting. We have folks from Switzerland, Mumbai, Chicago, Milan. I'm so sorry, more Chicago. But yeah, no, I'm really excited to see everyone this morning. This is kind of a fun group. So good morning. And thank you so much, Anna, for being with us today. So welcome to the Chicago Kotlin user group.
Thank you, Amanda.
Yeah, it's we've had Anna on before. She is a Kotlin GDE for folks that are unaware. She is a Google developer expert, and we've been lucky to have her on the show before in the past. So, Anna, what we're going to be talking about KSPs and compiler plugins today. What should we be looking for in the talk?
Well, I would like to focus on several approaches to optimize Kotlin multi-platform common code because sometimes it could be really tricky to make several things or duplicate several boilerplate. And when we work with native platforms, we know that there is native approach for Android and iOS, but it could be really tricky to find something common to apply it in common code and to not duplicate our work for other targets. So I would like to show such approach and to talk about some nuances that could be applied and what could be done with native technologies from Google for Kotlin without any third-party library.
Oh, okay. That's really, really exciting stuff. Yeah. Really looking forward to it. I think, we don't see a lot of Kotlin multi-platform cases, just like as a continuous case study. So, like looking at the tooling side of things, like really excited for it. Anna, I hope you don't mind. I'm going to take you off for a few minutes. I'm just going to run through the logistics and then I'll give you the floor back and we'll take it from there.
Okay.
Okay. Thank you so much. Hold on just a sec. Okay. Yeah, so before we have Anna back to give her amazing talk, yeah, I just wanted to say hello again to everyone. Welcome to the Chicago Kotlin user group. If you're not familiar with our group, we believe in being inclusive. So, Chicago Kotlin user group is an inclusive group. Be curious, ask questions, and avoid assumptions, and do anything to continue to grow trust, empathy, and friendship. Okay, we are always looking for new speakers. We do have an open CFP year round. There should be a link in the description of the video. It's a great way to expand your network. It's a safe space to practice talks, and it looks great on a resume. We've had a mix of experienced speakers and new speakers, and they've all been really great talks. So please don't be afraid to share something because we really love original content. So we do have a couple ways to stay in communication. Of course, there is this YouTube channel. There's also the Kotlin Slack. We do have a Chicago channel. And then we also have a Twitter for Chicago Kotlin. So for live interactions, we do have a YouTube chat. Please feel free to ask questions during and after the presentation via the chat. Anna will be keeping an eye on the chat and she'll be answering as she sees it. So don't be afraid to ask questions during the presentation. Okay, without further ado, we're going to go ahead and switch. And yeah, so without much further delay, Anna, I'm gonna let you have a go.
Thank you very much.
Thank
I'm
you.
ready. So
Wonderful.
let's begin. And I hope my talk will be interesting for you and will not blow up uh, your mind, but will be useful.
I'm looking
Yes,
forward to
and
it.
yes, though Kotlin Multiplatform still be not final release and it's going to be beta, and we waiting for beta release this year. We hope so. There are a lot of ready-made solutions and production cases that could be available for you. So now we will talk about how to optimize something. And of course, I will make some kind of introduction to Kotlin multi-platform for those who are not working with technology and who would like to know more about this and to understand why we need to optimize common code and what is a common code in Kotlin multi-platform at all, what is the root of this problem and what is the problem at all. So, my name is Anna Zharkova. I'm a mobile developer at Usetech software company. And here is Kotlin Symbol Processing and Plugins. At first, few words about myself. Thank you very much, Amanda, for introduction. But also, I'm not only Kotlin GDE. Also, I'm not only Android developer, but I'm both native Android and iOS developer. And also, I'm cross-platform developer, so I'm multi-developer. And also, I'm a tutor in Otus platform at course iOS Advanced. And I'm a woman TechMaker ambassador. So you are welcome to ask me about all the multi-platform and all the mobile development, except the Flutter because I'm a junior developer in Flutter at the moment. I'm just learning it. So let's take a look what we will talk about today. So at first, small introduction in Kotlin multi-platform and its conception. We will talk about this technology, and then we will take a look at two approaches to optimize the work in Kotlin multi-platform and especially in its common code. It will be Kotlin Symbol Processing, and then we will take a look in how to apply Kotlin symbol processing in such practical case as dependency injection, and then how to apply for the same purpose compiler plugins written with Kotlin technology, and then we will compare both technologies. So let's begin. What is Kotlin Multiplatform? This technology was developed by JetBrains company several years ago, and it is a cross-platform development technology. It is a special kind of SDK. It's not a framework, and this SDK allows you to put all the code you would like to share between several platforms and make it common. So you could provide some kind of common code. For example, it could be um, everything except UI or platform specific things such as work with some kind of sensors or maybe two platform specific logic. And all this code could be placed together in one model, and then it will be shared and compiled with different compilation processing. For example, it will be used as Java Virtual Machine for Android and LLVM for iOS, and then it will be processed different formats of library. So it will be jar library for Android and framework for iOS. So you could use these compiled libraries separately for your targets, and then you could use all this shared code. Why it is not a framework? Because there is no mechanism to work with the UI. It's only for sharing and specifying common code. Of course, there will be some nuances, and let's take a look at this. Um, Common code and common model of shared code has special structure in Kotlin multi-platform. It use some common part, and then in this shared code, there are some platform-specific parts. All these parts use Kotlin, but they use a specific version of Kotlin. For example, for common code, it will be common version of Kotlin, but for Android specific part, I'm not speaking about a native Android application, but for the library that will be used on the Android application. For this part, there will be used Kotlin GVM. For iOS specific part written on Kotlin will be used Kotlin native. Also, if you specify here the work with desktop, Linux, macOS, it will be also Kotlin native. And for web specific part, if you're making not only mobile application but both mobile or web or only for web, there will be a Kotlin JS version. So every part of this model has its own version of Kotlin. And of course, if all these parts specified for special targets, there will be some nuances working with native SDK for all the targets and communication with common part. So in these cases, we need to provide some kind of common solution that will support all the targets we need to specify. As a practical case, let's take a look at manual dependency injection solution. When we work with Kotlin Multiplatform application, we could use shared model only for sharing sources or data models, and also we can share some kind of services. But sometimes to provide the maximum sharing experience. For example, to make total sharing application with a common architecture solution, we need to use some kind of dependency injection solution. It could be some ready-made library such as Coin, for example, or maybe something else, or maybe it could be some kind of manual dependency solution. And why we need to use dependency injection in this shared logic, because we would like to make some kind of whole application, not only the separate parts that could be used separately on your native platform. So in this case, we need to specify dependency injection solution. And if we use this solution, there will be some nuances of this. And these nuances will depend of what targets will be used. For example, different version of Kotlin means you need to specify different memory memory support, or maybe different concurrency for this. So all these nuances should be noticed on your common code. And when you use several kinds of solution, let's take a look at some sample. It is my multi-platform dependency injection library. And it provides some kind of container, and this container has several resolver that will find a sample or maybe create a new sample of some type, dependency depending of the registration information, for example, the scope, the rules of storing, and etc. So this is the manual injection solution that will be injected in your shared model. And when you use this dependency injection solution, there is also a lot of boilerplate. For example, there is a sample how to register the special types, also with specifying not only the scopes as rules of storaging, but also several parameters and the fabric to create the new samples of this type. And there is a lot of repeating code, a lot of boilerplate. So it's a really nice place to optimize all this code. When we talk about native solution, for example, when we talk about such solutions as Dagger that could be used on Android part, there is work with annotations, and a lot of code will be generated for you during the compilation. But we cannot use such solution as Dagger because Dagger use only Android specific code. So to optimize our code the same way, we need to create something that will support also multi-platform and will use and will be and could be used for both platforms because you cannot use Android specific code for iOS. So, how we could specify and optimize our code? We could generate common code the same way, but with Kotlin Symbol Processing technology that will process our annotations or modify existing files with compiler plugins. It is also the same way that will provide some processing of annotations, but uh, these technologies will process your sources differently. So let's begin from Kotlin Simple Processing. At first, after my mass introduction, let's take a look what is this technology and what it could be used for. Kotlin Simple Processing is an alternative technology to KAPT, but KAPT, Kotlin Annotation Processing Technology, could be used only for Android because it uses a lot of Java. And Kotlin Symbol Processing is a multi-platform technology and could be used not only for Android, but also for Kotlin native because it's supported. And of course, it could be used also for Kotlin JS. This technology was announced last February by Google, and it is compatible with Kotlin since version 1.4.30 and stable version of this technology from 1.5.31. Before the stable version, there were different versions with a lot of differences, and it was really hard to make some common solution, complicated solution, because at every new version with every new update you need also to update your code, and there will be no ensure that everything will be okay. But from the stable version, it could be used for all the platforms, and also the differences between different versions are minimal. So it's only the stabilization of every new version. So, what is the main purpose of this technology? Uh, Applying to our case, it will be creating annotation processor. For example, there is a sample of annotations that we will use in our code to prevent using a lot of boilerplate. So here is annotations for different kind of scopes, for example, graph and single for singleton, and also special kind of annotation to container that will store all our data. And also this technology could be used to build lightweight Kotlin compiler plugins, but we will not speak about Kotlin simple processing in this case. For compiler plugins, we will use another technology to compare them correctly. So let's begin from this. The main purpose of annotation processing and why we will use annotation processing is to analyze our code, then generate some common code for our purpose, and it will simplify our abstractions. Let's take a look how the annotation processing tool work. There is a schema of how KAPT work. KAPT analyze all your Kotlin sources, and then with the analyzing of abstract syntax tree, it will create some kind of Java steps for your code, and then these Java steps will be compiled for Java classes, and these classes will be compiled with your other sources. And there is the mechanism that is used in Dagger and other Android libraries. Why we will not use KAPT? At first, it worked only with Java, and it will not work with our targets. So it is not our case. Also, KAPT generates a lot of Java code. And there is too much code, there is too much time because Kotlin compiler has to generate all the steps before the compilation, and then we have to wait the end of the compilation. And you know that when we work with the Dagger and we have multi-model project, it will take a lot of time during the compilation before everything will be compiled and processed. And sometimes when there is not enough memory, we will get out of memory before we will get compiled sources. So the KSP is really better because it treats Kotlin as abstract syntax tree directly. So, and there is no need to create Java steps. So it will be pure and faster. And because there is no Java steps, it could be used for other platforms. And it's really cool. And also is compatible with Java code because it's Kotlin. So it's really a nice solution and it's really fast solution. Now let's take a look how to build our own processor. So at first there is some theory about this technology, and then we will take a look at our practical case. So please, will be patient. Uh, to process our code, we need to create some kind of processor. And also we need to create a processor provider to register our processor. So there is two interfaces. First one is Symbol Processor Provider. It will be used for our symbol processor provider that will create our own symbol processor. And our own symbol processor need to implement symbol processor interface, and there is a declaration, some methods. Take a look at process with resolver method, and also there is declaration of init method. In different versions of Kotlin symbol processing, there were different parameters in this method, and uh, so in different sources, depending the version of Kotlin symbol processing library, there could be different parameters. But the logic of this processor will be the same. So to register our symbol processor, we need to create our provider and then create a special resource to declare our provider. And now let's take a look at our own processor that will implement symbol processor interface. Here we will override process methods, and in this method we need to implement the work with resolver, and this resolver will recursively find all the data we are searching for. So it will visit all the files, classes, and functions we need to analyze, and it will accept several logic to find the entries of our annotations. And then, collecting all this data, we will create some code for our purpose. So, to analyze all the entries, we could create our own visitor, or maybe use another technology just with resolver. Visitor will find for us all the data about the declared functions, classes, other declarations in our file, and we will use the reflection information about all the types and components are used for our purposes. So here is a sample of implemented visitor with case visitor void class. So how our symbol processor will work? So at first it read all the information and analyze source program and resources, and then our processor will generate all the code or other forms of output we need to use, and then generated code will be compiled together with our sources. To save all our data that we will analyze and find, we will use Kotlin Poet technology. to create and generate new files with new entries, new structure, and it could be done really simply with this library. So at first sight, this technology not too hard because we could use several templates. Nowadays, there is a lot of different samples on GitHub, and we can use several templates to simplify our work. But there is several limitations to work with Kotlin Symbol Processing. When we work with several annotations, and for example, when we used annotations for several purposes in Java, we also, or maybe in Kotlin, for example, simple annotation processing, but not with Kotlin simple processing. We used annotations for different purposes. And when we begin working with annotations, we um, wait and we suggest that there will be some modification in existing code, but there will be no modification in existing code, and we need to generate new files, and then these new files should be processed with your sources. So your sources need to know all the names, all the entries, methods, and etc. So you need to prepare all the data and to use it correctly. The main limitation of all these new technologies is that there is still not enough documentation for different cases. Yes, there is a lot of samples, there is a lot of templates, but not enough documentation for different purposes. So every contributor of the technology and every enthusiast I think could write own documentation, maybe some kind of books about this, or also different kind of sources. So uh, let's create our own annotation processing. At first, we need to create a special model for our compiler, and this compiler will use special kind of symbol processing API. We need to add it in dependency section. So there is a special DevTools KSP Symbol Processing API, and also you need to use correct version and to prevent some problems. And of course, if you will use some kind of new version, sometimes you need to change something in your code to make it more stable, because there could be several changes. And also, we need to specify Kotlin JVM in plugins section. Next, if you will use KSP compiler module not only for Android purpose but for multi-platform, you need to specify not Kotlin JVM but Kotlin Multiplatform in plugin sections and Java library as ID in this platform section. Before the stable version, we need to create some kind of magic solution um, that need to use several special structure of our multi-platform application, multi-model application, and we need to generate everything for Android, and then all this generate data could be used for iOS. But nowadays, we don't need to make some kind of magic. It will be done everything automatically. Just specify your compiler model as multi-platform. A simple rule to use with multi-platform library. So here is our compiler section. So let's take a look how we will connect it in common module. At first, we need to specify using of KSP plugin in plugin section. Also, you need to specify the path to your shared module, and in this shared compiler module, also you need to specify not only implementation command, but also next you need to specify KSP compilation. And in this case, everything will be processed with KSP library, and then you will get some generated data. And also, you need to specify the path to all your generated data. Sometimes in different version of Kotlin and Kotlin Multiplatform, there could be different paths to your generated data, and unfortunately, IDE couldn't find this automatically, so you need to specify them previously. And the path of to your data should be declared for dependencies in common main. Also, there is sections to dependencies for Android main and iOS main. So these sections for dependency for your Android and iOS targets. So you could use different libraries and different version of libraries for iOS and Android, and there will be no problems with it, no conflict. But to use generated data, you need to specify this uh, in common main, because when you will specify separately path to generated data for Android and iOS, so you will specify it differently, there could be some kind of conflict, because you will get the information that the data was already generated, and there will be some kind of collision. So specify the path in common main section. Next, you need to specify Kotlin Poet to generate all your data correctly. And let's take a look how the generation and the processing will work. So here is this special schema. DI code symbol processor is our processor that will find and search and find all the data we need to use to in our solution. It will use special scanner, or it could be a visitor, and this visitor will analyze all our data and collect it together, and all these batches of the data will be next used in our special code generator to create and generate our new data that will be stored as Kotlin sources and then processed with our other sources during the compilation. So there is our symbol provider. So let's take a look at process section. In this section, we'll use our scanner, and this scanner will get for us the collection and the map of all the definitions we will search for. And then we will put all these definitions, all this data to our generator. And also you could specify it in the way you need to result. So if you don't need to get some default, for example, definitions, or maybe you need to use all this data in other way, you are free to use it in the what way you need for. So let's take a look in our resolver. Our resolver will use the default get symbol annotation method, and this method will search for annotations with special qualified name. And then we need to filter all the data in special version. For example, if we will declare it for class, we need to filter the classes. For methods, we need to declare it with methods. And then we need all the filtered definitions map in special structure, and then our data will be ready for analyzation. So the way you will map it in a special hash map or other structure depends from your task and your purposes, of course. I only show in my sample. So, and then when we will have collected all the data, we could process it in our generator to generate all the data. We could use all the commands of Kotlin Poet to create special structure, or we could also use some kind of templates to simplify our work. For example, here is my template. So what I am doing, I only create the class in what I put all my registrations. So I only simplify my task from the boilerplate code. It's my special kind of container, so I automate the work with container. So during the compilation, we will get the output that everything was found and everything was found correctly, and our annotation was processed correctly. And after the generation, I got the configurator, and this configurator contains all the data, all the registered data I have specified. So I used a special kind of annotations for my services, and automatically um, all the information about the registration with the information about scopes and several parameters that was analyzed from the constructor. All this information were written in this file. And what we have got, it is the same structure we have created previously manually, and then we could also connect all this data manually. So after the compilation, all the sources have been created and it could be used safely. So we can connect all the data manually and then check and use. But let's take a look at previous slide. It seems that the way we have connected this container to our code seems to be too overloaded, and there is too much code. There is really strange structure, so it could be also simplified. And in this way, we could also use some other technologies. Uh, at first, let's make some summary, and then we will take a look at other approach to compare with Kotlin Symbol Processing. So, the main problems of Kotlin Symbol Processing is that generated files are not used by default. And there is not too much documentation for different purposes. So there is not too much the templates of this solution. There is no default template for this solution, and every contributor, every developer creates own solution with own architecture and own structure. Sometimes it's really simple, but sometimes uh, it could be really confusing because there is no common rules. But I think that it will be fixed maybe some other in some other versions, and of course every contributor could be the author of own template and own architecture of this solution. So, and now let's take a look at another solution. um, I will let's return to this slide and fix and focus on this moment. Too much code and too long solution. Now switching to Kotlin compiler plugins. So Kotlin compiler plugins is another technology that could be used for processing code and creating some optimization. It's also the mechanism of reading and analyzing abstract syntax tree. And also the abstract syntax tree is analyzed and read directly. But the main difference from the previous solution is we're not creating and generating new files, new sources. We modify existing code. And also, it could be used with Kotlin native, so it's also multi-platform solution. So the solution could be really equivalent to Kotlin Symbol Processing. It will be really equal in our result, but we comparing um, creating new code and with generating new sources and modifying existing code. So let's begin. What is the structure of Kotlin compiler? Kotlin compiler plugin contains from two main parts. First part is Gradle part. It's a plugin register information and sub-plugin register information. So there is a lot of samples how to register your own plugin. So we will focus on Kotlin section because it is the main difficult part, and here is the main challenges. So Kotlin part contains from three components. First is command line processor. Of course, if you have no need to process some arguments, so will be no arguments. There is no need for command line processor. And then next one is component register. This is the part of your code that will be used to register your extensions, and the extensions is the main part where you will modify your existing code. So let's take a look at the structure of our plugin we will use for our dependency injection. We will use our plugin for two purposes. First one is injecting, and second one is registering. Registering is the same purpose we have used before, but there will be some kind of optimization that we will look maybe easy and simple, more simple than the previous solution and the injection version. So our plugin will contain first the registering information for our Gradle plugin, and then there will be component register that will register both extensions for our both purposes. First extension will work with transformation because we will use some kind of transformation to add some information for existing declaration. And second one will use a lowering technology because we will generate not existed code and add it in existed file, but without modification, some kind of bodies. There will be no transformation, but there will be kind of addition to existed code. We will use a container class lowering pass, and for every extension, we will use so we will use every extension for different processing. So at first, let's create our registration for our extensions. When you begin to work with Kotlin compiling, you will notice that there is IR prefixes in every command, in every entity. It is because compiler use IR technology as a backend. We will not speak a lot about this technology, but what could be said about IR? This technology used to process and analyze abstract syntax tree, but there is no some kind of specific platform work, and so it could be used also for multi-platform solutions. But the main purpose, but the main challenge of this technology, there is several problems with inner reflection. So you need to use, if you would like to analyze a reflection, you need to use some kind of special solutions, but we will not talk about the solutions this time. So uh, to register our extensions, we need to specify our component register that need to implement component register, and in main part register project components that will be overwritten. We need to register all our IR generation extensions, and for every extensions we need to specify, of course, the extensions, and also the project entry point. And also we need to add annotation auto service if we would like to register our component register automatically. So, and there is our first extension. To work with our extension, we need to specify the special path to every types, to every entry, to every method we will use in our work. And then we need to put all these things together. Every extension need to implement IR generation extension and override main generate method. And in this method, you get two parameters. First one is your model. So model is your class with to be analyzed, and also the context of your plugin. So if you need to specify some kind of types or maybe some kind of predefined information previously, you could put it here, or maybe all this information could be placed directly on your extension, or maybe some kind of the classes or the logic it will be used. So in this sample, we need to add transformation. So there is inject transformer, and this inject transformer will work with inject service annotation and the plugin context as entry point. So to connect transformator, we need to use transform method and add it in our model fragment. Model fragment, as I mentioned before, as an entry point of our class we will analyze to search the entries of our annotation. So there is our cases. First one is injection. Second one is add to container. Let's begin from our injection. Our injection will use inject service annotation, and this annotation will help us to simplify this code. For example, here we um, use a simple lazy method. In this lazy method, we call from our container the resolve function with the name of our class. But the main difference from the previous solution, we will use not the type, but the string, the class name, and it will be more easy for us to specify this string as a parameter, not the type, because there is a lot of struggling with inner reflection. So here is what we need to do. We will declare our mother service as a sample with inject service annotation, but with empty body. So we need to create body. So there is default body, and we need to provide same but automatically without any our boilerplate code. So let's begin. We will add our transformer that will help us to add the declared body. So we haven't specified body, but we need to transform the declaration to add this. Our transformer need to implement our element transformer void with context entity and override visit function new methods. Of course, if you would like to transform the class, you need to implement other methods. So in this method, we need to first check if the function we analyze, so this method analyze all the functions of your class from the entry point, and if this method has the specification of special annotation, we need to create special body for this declaration, or we need to do nothing. So of course we need to specify all the types, because during the compilation and using with abstract syntax tree, we need to put all these points together. So it looks really strange that we have to provide the paths for all these types. For example, for lazy function, there will be Kotlin lazy reference. Also, we need to provide the reference to type any for any type, and also for the methods that will be used to resolve the data. So here is the direct using of this method, not automated. And also we need to specify the entry point to call this method. In this case, I will use this kind of declaration. So because I would like to use the singleton, because we will call the methods from the outside of the container. We are not in container. We are calling from outside. So at first, let's create lazy field, because we will work with lazy field, and this lazy field will contain some kind of lambda. And here is how we will do this. At first, we need to specify some parameters of our field, and then with this field, we need to provide this initializer. And in this initializer, we need to specify some specification of this field. For example, we will work with lambda, so it will be local field with lambda origin, and return type will be the same we have specified before. So the return type of our function will be the return type of our lambda. And then we need to create a special kind of body for our lambda, and this body will be what we have previously specified in this lazy field body. And then we need to put everything together, so we need to specify for this body special IL call of this function with specification of return type and values type as parameters. Yes, KSP seems to be easy. Maybe not, maybe yes. Let's take a look for our field. So our field will use lazy type, and this will be the type of our field. Also, we need to provide some kind of stubs for the name, because there will be no name for this function, and also it will be a private field with the same offset and set as for the default function. So because it will be in the range of this function. So here is our method, and for this method we need to also specify the initialization, and to create this we need to specify special fabric function. So we have specified this as with the same return type and as local and local function for lambda. And it seems that we have done everything, but the main focus is what we will do in our body. To create body, we need to use declaration IR builder with special kind of block. And in this block with IR return command, we need to specify what we will return from the calling of our function. In this case, we could also call the constructor every time. It could be the most simple implementation for our case, but when we work with dependency injection, we not create the new sample of the type every time, but sometimes we need to get already existed element from our container. So if we need to create the element every time, we will use the calling of constructor, and this constructor will call, for example, primary constructor with empty list. So it is the most simple solution. But for our case, we need to do this. We need to call the resolve function, and for this function we need to put the parameter as type will be our any type, and also we need to put the class name as a value. So and then we need to specify the receiver of our function. The receiver of this function could be the main challenge point, because we are calling, it depends from what point we calling for this function. For example, when we call from the inside of the class that contains the method we are searching for, the method that the reference for this we are using at moment, we need to specify the path to the getter of this function. So we could use just some kind of getter because we are inside, and this getter will be used as a receiver of our function, and we from this receiver we will call the implementation of our function. But when we are outside, for example, in dependency injection solution, there is also a singleton. No matter if you don't want to work with singleton, there is also a singleton, but only in one level, and you need to call this singleton directly. In this case, it will be the most easy way to call this function. So your singleton need to provide instance, and then if it has instance variable, you could also specify the reference to your class, and in this case, it could be used as entry point to call this method. So there is really a main element in our logic. So when we call inside, we need to get the value of this object. And if we call, for example, from the field, that could be we could also specify the receiver, the function, or its parents, for example, just like this. In this case, the receiver of our function for our field will be the receiver of our function. Or maybe if there is no receiver for our function, there will be the parent class, and this receiver could be used to call the method. Yes, I understand that it's not really clear, and we all and everyone need to get good documentation, but there is a logic of this solution. So, and one more time, the receiver is the host method of this function field. In the case of our resolve method, it will be configuration operation. Configuration app, I'm sorry. And for every field, there will be a parent class. Now, let's apply our solution. Let's apply inject service annotation and build. Let's check the result. Comparing with Kotlin Symbol Processing, there will be no output, but there will be in build transform section, because we have used transformer, there will be several dex information. And in this dex information, there is several calls of the methods we have specified with this function. This is a screenshot from the final solution, but the mechanism will stay the same. So let's take a look here. In this section, we can see that there is the calling of the resolve function, and our resolve function have created for us the elements for mobile service and for network services. As you have noticed, mobile services use network services as um, some kind of parameters, but as you have noticed, there is inject service only for mobile services. So network service declaration will be created automatically. I mean, resolving of network services will be created automatically. But previously, when we have worked with Kotlin Symbol Processing, there was a lot of boilerplate while registering our service. So this is the same case we have solved previously with Kotlin Symbol Processing. Let's do the same, but with Kotlin Compiler plugin. In this case, we will automate registration, and for this purpose, we need to use annotations to create the information about the scopes and about the container. And what we need to do, we need to provide using our data the same way. So all the callings of our processing will create the add to scope registration for some kind of type. Also, we're specifying the fabric to create new sample and several parameters. And also for every parameter, there will be their own fabric. So all this boilerplate will be simplified. And to simplify registration, we will change the registration with type, uh, to resolving with string type, and also we need to use lambda parameter. So here is our method. One more time: add to scope method with string parameter that use the type, the class name, and the fabric. And the fabric is lambda. We have used lambda before, but in this case, it will be another way to work with lambda. Uh, in previous case, lambda was called automatically and we have processed the result of this lambda. In this case, lambda is parameter and we don't need to call the lambda at the moment we call the resolving and registering our service. So we are adding another extension, and this extension will use these new annotations and another way to work with data. There will be no transformation, but we will use lowering. And of course, to register new extension, we need to add a new registration for this extension in component registrar. And of course, new extension also need to implement IR generate extension, and this extension need to override generate method. And in this case, we will use lowering class also with specifying the plugin context and with lower methods. And in this point, we also need to provide the model fragment that will be the class that will be automatically analyzed. So model fragment, as we have mentioned before, is entry point for every class will be analyzed. So here is our lowering class for analyzing data. It needs to implement class lowering pass and override lower function. Of course, also in this function, you need to check if this class is correct and need to be analyzed. If there is no need, we continue with other classes, or we will add our data. In this case, we need to create new methods. So we have existed code uh, and there is no existed declaration, but we need to create these methods. And also we need to add the call of these new methods to existed function because of course we need to have existed entry point to be called. And in this case, we also need to create new body. We again use declaration IL builder and IL block builder, IR block body, I mean. But in this case, we need to create a call of our add to scope function with new parameters. So every time we need to add call, we need also save the previous statements and then add new statements at the end of our body of our methods. So it is not the transformation. So of course, it could be used with transformation, but in this case, it could be also used in lowering. So, and for new call, we need to get the lambda as parameter And this new parameter also need to be put as a value argument in the calling of our new function. The reference to this we have specified before. And as a receiver, we will use the link to the object, and it will be also our container. Yes, or maybe if we will call from the getter, for example, from the inside, also we need to specify the getter function. So let's take a look how to work with Lambda. There is no correct information how to use the Lambda. You can find the samples how to use Lambda in some sources of existing plugins. For example, I have searched for this instruction for 1 week, and I have found it in JetBrains sources. So here is the right way to create the Lambda function as a parameter, because there is no need for this Lambda to be called just at moment. So there will be only the declaration of this fabric, and this fabric will be invoked at the moment it need to be invoked. So also in this moment there will be anonymous function, so specified as anonymous, with the same return type and with local function for Lambda. And there is our sample Lambda argument. So this instruction was found in JetBrains sources. When we have created our Lambda, we need to specify here the body, and the body will be our fabric for our special type. For example, here will be used primary constructor. And for this primary constructor, we need to analyze all the value parameters, because there could be several value parameters. For every parameter, we need to specify the temporary result of the calling of special constructor. And also we need to specify here the same receiver we have used before. So it will be also the entry point to our configurator. And also we need to specify here as a parameter, maybe here could be also your Lambda, and also here could be the class name to find this element. So there is what will be specified in your constructor for your fabric. So here is the body. And in other elements, the same logic was used. So there is no lazy field, but there is only the call of the methods with specified class name and specified Lambda parameter. So in this case, lowering could be really easy than just transforming. For example, for me it was more easy, though I was searching for the instruction. So, and here is how our annotation will be applied. So at every point, at every service need to be registered, we need to put some annotation. In this case, I used only single annotation, and then I also place a container here. So this means that I use configuration app as an entry point. And I also specify here several simple elements that will be called for simplifying the logic. So here is resolve and add. So we need to use both of them for our purposes. For example, add was used to register, and resolve was used to get information. And also when we specified Lambda fabric, we have used resolve function. And all these annotations was placed, the result of processing was placed in setup function. So, and now let's check our decks. So at first round, we will got the calling of network client. So here is the first round. As you can see, there is different versions of setup method, and this means that every time we have processed this um, element and added new statement, there were created new text element. At first one was added network client, and you could see that there is a call of instance and the special method. And on the second round, were added movie service with using of network client as a parameter. And network client was resolved from our configurator, and the information about movie service were added in setup function. And when we will connect everything and check, everything will be okay. Well, it was really hard. And what could be told in summary for this technology? At first, um, it allows you to modify existing files, and it's really lightweight because there is no generation of other sources, no other sources, no no problems with the weight of your application. But it also stable and not stable and experimental technology. Everything changes, and there is not another documentation. You have only the samples of different people. Um, when I was creating my sample, I searched for different samples in GitHub. I searched for different elements, and what have I found was the sample of, for example, um, the of Brian, who had created super cool threads for about how to use Kotlin compiler and template element. And also there were several samples. For example, there was sample of Arkady Ivanov how to use the Kotlin compiler with personalized annotations, and they were sample about class lowering to add in information. There were library of Dmitry Shustov how to use lazy fields, but there was a really problem with searching how to deal with lambda as a parameter. So the lack of documentation, I think, is the main problem of this technology. And when we got a normal documentation, everything will be easy. So, and there is a summary for this section. Thank you for your patience. KSP is faster than KAPT, better performance. It's really a stable technology, but it still be developed, but it still develop its stable version, and it supports Kotlin native. It could be used in Kotlin Multiplatform, and you could use it in the same way we have used Dagger in Kotlin in Android. I mean, plugins also could be used with KSP, and they could help you to make lightweight and flexible solutions. They could be used together, but there is a problem that there is a lack of documentation there, and you need to use other samples to find something out. So thank you very much for your patience. Here is the sources, and thanks for listening, and I'm ready for your questions. Whew. I saw that there is blurring for your minds, and also it blurring my mind too. So yes, but it's really cool that we could use something to optimize our technology.
Yeah, it blew my mind. That was an incredible talk. Thank you, Anna. We actually do have some questions. First one comes from Rob. Does the Kotlin compiler plugin classes come with the Kotlin KSP library?
Well, um, Kotlin compiler classes with Kotlin KSP library. Well, no. Kotlin compiler. Well, do you mean Kotlin compiler? Yeah. No, Kotlin compiler plugins doesn't depend from Kotlin Symbol Processing. So it is a native technology that already included in your Kotlin. And you could use it not only with Kotlin Multiplatform, but you could use it with the Android application or maybe some kind of Kotlin application, for example, Kotlin for backend. Um, I remember that last year, Karen Alexander Manoid showed how to use compiler plugin with Meta that was used for Kotlin for backend. So you could use Kotlin compiler plugin functionality without Kotlin symbol processing. But if you would like to combine all these solutions, there's also no problems with this.
Yeah, and I'm gonna kind of like add a little more clarification as well. The Kotlin compiler plugin classes. So that actually, there's I don't know if there's like specific Kotlin compiler plugin classes. Like what it really is you literally open up the Kotlin compiler and you create like an extension. That's what a compiler plugin is. So when Anna was talking about all those registration bits, those were several components she was registering to intercept different phases of the Kotlin compiler. Um, yeah, sorry, I don't know if you wanted to add on to that. There's more comments coming in, and I'm like, oh gosh, I got to start reading some of these. So, yeah, I don't know if you had more to contribute for that particular point. People are really excited though.
Yes, thank you. Uh, so here is some other questions. Could a 501 for iOS? You could also this depends of where you have specified your I understand that this is a question about Kotlin simple processing. You could specify your annotation processing, not a common main, for example, but for maybe the part of iOS main or Android main, and then you need to specify the path to your generated files differently for iOS main and Android main. In these cases, you will get different implementations for Android iOS, or if you don't need to get it for Android, you could do it for iOS, and also the same contrary when you don't need to get it for iOS. And let's say that I had to implement a specific logic like date. Um, well, if you use a platform specific logic like date uh, output for Android, this is question. I have read only the second part of the question, and the question was about actual expect elements. No, this is not about Kotlin Symbol Processing, but about how to use expect actual technology when you declare with expect several instruction and redefine with actual for Android to enter separately.
Okay, is it muted? Hold on. Sorry, I had some issues with some slowness here. Yeah, these are really great questions. Don't be afraid. I think we got time maybe for like one more question if we have it um, from someone in the audience. I guess, hush. Sorry, talking to my bird. He's a little crazy right now. Anna, like, how were you able to write your own logic without any of the documentation? That's usually like the hardest part. Like even like setting up the boilerplate too is kind of a challenge.
So, to prepare for my talk, I used the documentation. At first, it was an article by Arkady Ivanov, who wrote last year about how to use compilers for optimization in Kotlin multi-platform as an alternative to KSP, and I was interested with this technology. So, and I tried to use something. Um, when there is no documentation, the best friend of every developer is a Google and Stack Overflow. If you have found something on Stack Overflow, you will you will find something by Google. And there was the series of posts writing your second compiler plugin, and there was a talk writing your first compiler plugin. It was really blowing mind information. And with the second one, with a series about writing a second compiler plugin, I think that Brian is really sent man, and he deserved to get a statue from gold. I think so, because he helped a lot of people to create this. So I tried with using some samples. And where is no other samples, we also searching for something with GitHub. And yes, and
Sometimes that's
yes,
the
and
best.
with also when we sorry, there is something laggy noise. Could you repeat one again?
Yeah, I said, yeah, sometimes that is the best way to, like just see other complete examples so you can kind of like compare the boilerplate.
Yes, there is a specific of our work and how we all learn, that we learn from other developers using their samples. So, and then I tried different samples and tried to find something that could be the first part, the start point from to create my solution. So, and also, I analyzed several sources from JetBrains. For example, for my purpose to create lambda as a parameter, and yes,
Yeah, I was
I,
like, I don't know how I'd get that on my, like if I was someone who maybe didn't know the compiler as much, I'm like, how would I even? Yeah,
so I think it's really be a nice moment that to write a post about all these things, and also to provide the links how to deal with lambda as a parameter. So
that would
because
be
there were not such sample, and think I will help several people to deal with this. I understood that many companies that have already provided their own solution with Kotlin compiler plugins, because that is not too much new and fresh technology, though it is in beta stable moment, not a final release, but already there is implemented solutions.
Yeah, I think we have time for one last question. We got one last one. It says, sorry, missed the beginning of the presentation. So this might have already been covered, but can KSP hook into and generate code from build.gradle.kts files?
Um, no, KSP couldn't be used to analyze build a Gradle KTS. I think for to analyze this, it will be more flexible and more correct to use some kind of plugins, not compiler plugins, but some kind of plugin instructions that will be analyze and process your build Gradle KTS files by default. And there is a lot of such solutions, and there is also several instructions.
Oh my gosh. Sorry,
You have muted.
the computer is lagging a little bit, but yeah, that is our last question. Anna, thank you so much. This was an incredible talk. Would you mind sending some of the links after so I could just like post it in the comments and in the description. So I think folks are really interested and would love to follow up with some of these things. Yeah, it was a really great
Oh,
presentation.
oh, thank you. Yes, of course, I will put all the links and I will share it with you, Amanda, to provide easy access for people to
Yeah.
these sources. And also, I would like to specify here several moments. So I have provided in this talk, and also I would like to share my presentation, and there is a links to my KSP template. So I have prepared a template for people who would like to create their own KSP solution. So I think it will be easy for them to reuse it. And also there is a sample of the I plugin that use injection. So you could search something and to cut it off, or maybe to create your own solution with my basis. So there is a way that we share the knowledge.
Ah, it, that's a I think that's a beautiful thing. That's the wonderful thing about open source, and it's great because writing compiler plugins is relatively stable. There's just not a lot out there on it, so we're kind of at a really interesting time in compiler plugin writing. It's kind of like there's not a lot out there, but you can do it. I think there's a reason why it's widely accessible, but it's still just it's the coolest thing. It really is. Thank you so much, Anna.
Thank you very much. I was really happy to join College Care group today.
Yeah, and I can say I think everyone else on here would agree. We're really happy to have you on here. This was an incredible presentation. I can't wait to have it, trimmed down, and I'll be sure to let you know like when the edited video is posted. Yeah, thank you, Anna, and thank you all for joining today. It was really great to have everyone on. Wonderful audience participation. It makes it really fun to do these meetups, and like I said, this is just incredible content. So don't be afraid to submit your own content. It can be projects, it can be anything you do at work, it can be maybe for another talk. So please, we have some upcoming Kotlin user group meetups. I just have to figure out some dates, but we do have them. But we're always looking for new speakers. Thank you again, Anna. This was just really great presentation.
Thank you
All
very
right.
much.
Yeah, and thank you, and have a great day and have a great night for everyone else. Take care.
Have a nice weekend.
Bye.